Good morning. Today we are doing laws of cosine. So yesterday we did laws of sines, which if you remember was the sine of the angle over the side of the angle equals the sine of the other angle over the side of that, and so on and so on. Well, you don't always have all that information that you need to use laws of sines. Laws of sines is easier than law of cosines, but if you don't have the information you need, then you get kind of stuck there. So we're going to talk today about laws of cosines. And again, we have an ABC triangle, and these are the notes that you should have downloaded. Now, I know the formula looks crazy complicated, but let's just step back for just a minute, and let's go back to Pythagorean's theorem. A square plus B square is C square. Okay, easy enough. And if you look at the law of cosines right here, you'll notice we have an A square, we have a B square, and we have a C square. So basically we're just using a manipulation of Pythagorean's theorem, but it's not on a right triangle. So keep that in mind. So what ends up happening, and this is the complicated part right here, or the part that's different if you would, you have the 2AB cosine C. So you're just going to have to kind of memorize it, but a couple things that are easy. If you have the C here, you're doing cosine C, so your end pieces have to match. My pen just ran out of ink and I don't have another one, so I'm going to give you some blank screen for just a second. Let me get a pen. All right, sorry about that. So, and then in the, whatever your square is right here, that's this piece here, 2AB. So what do I mean by that? Well, this is if we're looking for C square or cosine C. You could also be looking for the B value or the A value. So let's just say if we're looking for the B value, then instead of starting off with the C, we would start off with B square is A square plus C square. So there's my Pythagorean theorem. Now, the 2 stays constant, minus 2, these two pieces here, AC, and then cosine B. So again, pay attention what we've got going on here. Our end pieces match up, cosine B, B square, and whatever my squares are here, get multiplied by 2. Get multiplied by 2. So not too bad. Now, what if we're looking for the A square side? Well, then we would have A square equal, well, clearly, B square plus C square minus 2BC, and then cosine of A. All right, and this should be a capital B because it's my angle measure. Okay, now you don't really have to worry about the cosine C. That's just the manipulation of moving the A and the B and dividing out. It's just showing you that there's an algebraic manipulation involved if you want to. All right, so here we go. Let's start with example 1. Given triangle ABC. So let's draw our triangle. And we know that angle B is 35 degrees. Remember, this is side B, this is side A, and this is side C. Opposite your angle is your side. They're telling me that side A is 5 and side C is 6. So let's think about this. We have angle A, angle B, angle C, side A, side B, side C. They've given us angle B. They've given me side A and side C. So you should realize at this point that law of sines is an impossibility, because remember, and let me just jump up here and write this, I have to have the sine of A over the side of A, the sine of B over the side of B, and the sine of C over the side of C. You have to have at least one complete set there before you can proceed. So if I tried to do sine B over B, I'd have variable B. I could look for sine C, but I have variable sine C. I have the length, but so that gives me 2 variables in that problem, and of course you can't solve that. So what can we do? Well, there's law of cosines. So we're trying to find B. So that's your leading indicator right there. So we're going to start with, okay, well, if I'm trying to find b squared. And I know that's a squared plus c squared. And then I remember minus 2, these two pieces here, ac. And then all that gets multiplied by the cosine of the piece here, b. So there's our initial equation. B squared is a squared plus c squared minus 2ac cosine b. All right, well, let's plug in what we know. We don't know b, but we do know side A, and we do know side C. Okay. And we know angle B. So cosine 35. So everything in that equation is filled out at this point, and all we have to do is go after the value of b. So we're going to be a little careful here. Sometimes students get a little over anxious to put pieces together that don't belong together. So hang on just a second, let me get this on the screen. All right. So we've got 25 plus 36. So I have b squared is, I'm adding these, 61 minus 2 times 5 times 6 gives you 60 times the cosine of 35 degrees. Please, this is where students usually make their mistake. They'll say 61 minus 60, but you can't. You have to multiply the 60 by the cosine of 35 first. So, and let's make sure you're in degrees, because my equation's in degrees. So I have cosine 35 times 60. All right, so b squared 61 minus 49.149. And we're going to take the square root of that. And we end up with a length for b of 3.442. All right. So again, it looks a little intimidating, but it's really not that difficult. It's just locking into what it is and when you need to use it. All right, let's look at example 2. Given ABC, of course, here we go again. With A equal to 6, B equal to 5, and C equal to 7. So now, again, they've given me side lengths, but I don't have any angle measures. So they're asking us to find angle C. We're going to start with C squared. A squared plus B squared minus 2AB, right? And then what has to match on the end? The cosine of my beginning angle, the cosine of C. All right, so here we go. We're just going to plug in what we know. We know C. So I have 7 squared is 6 squared plus 5 squared minus 2 times 6 times 5 times the cosine of C. So this is going to turn into an inverse problem because we're looking for the angle that has this cosine. All right, so again, be careful with your math. 49 is what, 36, 25 minus 60 cosine C. 30, 40, 50, 61. Okay, see if we agree. You're going to move the 61 to the other side. 49, 59, negative 12. Okay. And at this point, we're going to divide by 60. So I've got 12 divided by 60. I'm going to use a decimal. So the cosine of some angle is 0.200, or 12 over 60. Okay, so what do we do now? Well, of course, we're going to, what angle has the cosine 0.2? And you get 78 degrees. So I know that angle C is 78 degrees. I would not round that up. 78.4 isn't going to round to 79. So basically, just a lot of algebra that looks way more intimidating than it really is. All right, let's move on. Now, one thing that's a little important, of course, it is easier to use laws of sines than laws of cosines. So you can then move over to law of sines. But if you're looking for an obtuse angle, you don't want to use the law of sines. It runs into a problem. We can talk more about that as we move on. So if you are looking for what you think may be an obtuse angle, don't use the law of sines. And of course, that'll always be your largest angle on the longest side. So here we go. A triangle has sides length 6, 12, and 15. Find the measure of all the angles. So now we're going to be doing multiple steps as we move through. And we have all our side measures, but we don't have any angles at all. So we're going to be forced into law of cosines. So here we go. We've got A, B, and C. It really doesn't matter what you apply to what, so I'm just going to call A 6, B 12, and C 15 because they're not giving me any direction there. All right. Knowing what that paragraph says above, laws of sines cannot be used to find obtuse, let's go ahead and find angle C with laws of cosines because clearly it's going to be our largest angle. So don't run any risk of messing it up with laws of sines. Let's just go into cosines. So I'm looking for C. So I'll begin. C square, A square plus B square minus 2AB cosine C. Okay, so I'm going to have what? 15 squared is 6 squared plus 12 squared minus 2 times 6 times 12 times the cosine of angle C. 225. Okay, and again, please resist the urge to subtract this 144 from this 144. You've got to multiply these together first. All right, so I've got 70, 180. Okay, let's see if we agree. We're going to move the 180, 45. And then divide by negative 144. Okay. So again, first of all, can I have a negative cosine? Of course you can. Your cosine values can be anywhere from negative 1 to 1. So that's not a concern. So now, let's see if I'm on the screen. I am looking for the angle that has the cosine negative 45 divided by 144. And we get 108 degrees. What angle has the cosine 45 divided by 144? Negative. All right, so I know that angle C is 108 degrees. Now, you can run all this back through with laws of cosines again, or if you want to find the other measures, now I've got a matching set. Now I have the angle for C and the side of C, and I've got A and B side lengths. So now I can jump into law of sines. So I can say the sine of 108 over 15, there's the part for C. And let's go after angle B. I know angle B can't be greater than 90 degrees. So let's go there because I've only got 82 degrees left. So sine B over 12. Okay. So I've got 12 sine 108 over 15 is the sine of B. Okay, so you end up with 0.7608. And what angle has this sine? And you end up with 49.5. I'm going to call angle B 50 degrees. So much easier than law of cosines. Not that it's easier math, it's just fewer steps. So much less complicated, and of course less chance to make a mistake. So angle B is 50 degrees, 158, 60, so I know angle A is 22 degrees, and there's the entirety of the triangle. Okay, so you can shift. You're going to start with law of cosines, you're going to shift into the easier law of sines, and then you just subtract from 180. All right, let's see what we have on 4. They're giving me side A, side C, and angle B. Again, I don't have a complete set. I can't start with law of sines. I'm going to draw my triangle. A is 7, C is 9, and B is 34 degrees. Side, angle, side. So it's really up to you where you want to start. Because I have angle B, I would start there. So B square is, well, what's left? A square plus B square is C square. That leaves me A square plus C square, Pythagorean's theorem, minus 2, whatever is on the right side, AC, and then you're going to bookend it with cosine of angle B. So again, you start with the letter B, you end with the letter B. The A and C stays in the middle. All right, B square and now it's just a straight line equation. So oh, you can't see that, sorry. So I've got 130 minus 104.458 gives me B squared, so square root of that, B is 5.053. There's that length. And that tells you two things. Number one, the length of B, and number two is clearly that is going to be your smallest angle in the triangle. All right. Now, I don't know what angle C is going to be, but I know it's going to be the largest angle. So again, I'm going to back off the law of sines for that, and I'm going to say the sine of B over B is the sine of A over A. So I've got sine 34 over 5.053 is the sine of A over 7. Seven sine 34 so here we go. And what angle has that sine? And we end up with 51 degrees for angle A. And then, of course, that makes angle C 180 minus 34 minus 51. Yes, 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 I know I can do it in my head, I just don't feel like it. So angle C, 95 degrees. Okay, so let's do some practice problems. The form you should be looking for now is A33. It has a little 6 written next to it. Looks like this. Take just a minute and find that, and then we'll get started from there. Let me put these notes away while you're doing that. exactly what I was looking for. All right, here we go. We have triangle PQR, and they have given us side P is 3, side Q is 8, and angle R is 50 degrees. So side angle side, we're going to use law of cosines, of course, and we're going to look for side R. So I've got R square, P square plus Q square, right, minus 2PQ times cosine R. And if I were you, I would write that out every time. It makes it so much easier to lock it in. So I've got R square, 3 square plus 8 square there you go. Okay. Again, resist the temptation to subtract those. I don't. You can add 9 to 64. I'm sorry, that's not showing up. 2 times 3 times 8 times cosine 50. 30.853. So 73 minus that. Take the square root. And you get an R value of 6.492. Okay, now again, you don't have to jump through that hoop again. Now that you have a complete matching set for law of sines, you can just go from there. I would not look for angle Q because, again, that's the longest side in the triangle, which might make it an obtuse angle. So we're going to look for angle P instead. So we've got sine 50 over 6.492 is sine P over 3. Okay. So 3 sine 50 divided by 6.492. So what angle has that sine value? And we get 21 degrees. Which means our only missing piece is angle Q. So 180 minus 21, what was the other one? 50. So angle Q is 109 degrees. All right. Let's jump down to 3. They're giving me 3 side measures, A, B, and C. Clearly angle C is going to be my largest angle, and I think that's what I'm going to be looking for. So I have A, B, C. I have 8, 6, 109. That looks like, I'm sorry, that is an angle measure. That is not a side measure. This is an angle measure. It just doesn't, it didn't print right. Okay, there we go. So now we're going to be looking for side C. So we have C squared okay, see if you got that written properly. Okay, so now C squared is 8 squared, 6 squared, cosine 109. And again, now it just I did something wrong. I typed something wrong in here. Just a minute. Okay. Okay, you're going to notice your answer here is going to be negative, which means you're adding it. So your C square is going to be 131, 254. Does that make sense that we'd end up with a negative answer there? Well, think about your unit circle. 109 degrees is going to be in quadrant 2, right? And my cosine values in quadrant 2 are negative. So that makes perfect sense. So when you take the square root of 131, 252, you get a length of the C side of the triangle of 11.456. So again, if you get that negative answer, just think where your angle is and what quadrant you're dealing in. And then you're good to go. Okay, I've got the entire set of C. So now, and I know neither one of my other angles is going to be obtuse, so it really doesn't matter. So now I'm going to do sine of 109 degrees over 11.456. And I don't know, let's find B. The sine of angle B over 6. Okay, that's mainly just a force of habit. I usually find the smaller angle when we're dealing with this. So we have 6 sine 109 divided by 11.456. And what angle has that sine? So we have angle B is 30 degrees, which makes angle A 41 degrees. Okay, let's move on. Five and 6 and 7 change up the game just a little bit, and let's think what we got. We're solving for a missing measure. So now, way simpler than laws of sines and cosines. Now we're going to be looking at our trig functions. And what do we know? We've got an angle, we have an opposite, and we have an adjacent. So which trig function pulls in opposite and adjacent? The tangent of that angle is 16 over 12. Easy after what we've been doing. So what angle has the tangent 16 divided by 12? And that angle measure is 53 degrees. Okay, let's look at 7. Think that through. You're looking for an angle, and now you have adjacent and hypotenuse. So which trig equation? Hopefully you're remembering correctly, and it's cosine. So again, inverse, what angle has the cosine? 17 over 26. And angle X is 49 degrees. All right, we've got a little bit of time left, so let's go back and work out problem 2. I'm not going to be saying much during this. You can just refer to the screen. I want to make sure you're on the right track. Here we're getting 3 sides. So the question is, why would I choose to find C first? Well, I know it's the longest side, therefore it might be obtuse. I don't want to depend on law of sines because that's not going to work for me. So I'm going to use law of cosines, and then if it is obtuse, I know I'm covered. That's why I'm starting here. So we have 13 squared. Again, please, please, please resist the temptation to call it 113 minus 112 is 1 cosine C. Don't just, you can't do that. They're not the same animal. You can't subtract them. Be careful. So we're going to move the 113. So the cosine of angle C so what angle has this cosine? And we made a wise choice because angle C is clearly obtuse. Angle C is 120 degrees. Okay, so what next? Well, you can run back through laws of cosine, but it's so much easier to jump over to law of sine. See if you agree. Okay, let's go look at problem 4. Same type of problem. Same logic as before. If C is the longest side, it's going to be the largest angle. Sorry, I just realized that's not on the screen. Okay. Pretty straightforward. Now sine 89 over 19, sine A over 12. I know there's no chance it's going to be obtuse, but still, I go with the smallest side when I do this. So I know angle A is 39 degrees, which makes angle B 52 degrees. Okay. Pretty straightforward. And the final problem of today, we're looking for side A and side B now on angle 6, or triangle 6. So you really have two choices you can take here. We know our angle measure, and we've got an opposite. So opposite over hypotenuse or opposite over adjacent. It really doesn't make any difference. So let's just look at both of them. Let's just say we take the tangent of 38 degrees and opposite over adjacent, right? So in that case, the length of B is 19 divided by the tangent of 38 degrees. So length of B is 24.318. Okay. If you had decided instead of using tangent and you had used the sine of 38 degrees, then you would have had opposite over hypotenuse. So now we're solving for A. So length A is 19 divided by sine 38. So we get an A value of 30.861. So how do we know if they were right? Well, clearly Pythagorean's theorem. So we know they're right triangles. 19 squared plus 24.318 squared, and the square root of that is 30.860. So either method you choose, if you're looking for A and B, you're going to end up with the same value. It doesn't make any difference. I think we're a couple minutes early, but that is fine. We're going to stop there. And our next session will be laws of sines and cosines. What do you use and when do you use them? Thank y'all.